Big Data Architecture in Banking Sector, SADT IA2, by roll number 171 Janhavi Komurlekar, 174 Nabodita Choudhury, and 176 Arpita Saxena. Introduction. This paper discusses the role of software architecture in designing scalable and secure big data systems in the banking sector. It highlights the potential benefits of big data technologies in the banking sector and provides insights and solutions for addressing the challenges of designing scalable and secure big data systems. The paper emphasizes the importance of developing effective big data systems in the banking sector and provides insights into how these technologies can be used to improve various aspects of banking operations. History. So in this flowchart, we can see how much big data and banking has evolved since the mid-2000s all the way up till 2020. In the mid-2000s, we saw the emergence of Hadoop and big data technologies. MapReduce and other Hadoop technologies started to emerge, making it possible to process and analyze large and diverse data sets. In the early 2010s, personalization and customer insights were seen. Banks began leveraging customer data to provide personalized recommendations, offers, and services, improving customer retention and cross-selling. In 2010, we saw big data being used in regulatory compliances. Banks adopted big data analytics to ensure compliance, manage data quality, and produce the necessary reports. In the late 2000s, there was fraud detection and cybersecurity. Analyzing patterns of fraudulent behavior and monitoring network traffic became essential for protecting customer data. 2012 saw advanced analytics and machine learning. These technologies helped in areas like credit scoring, fraud prevention, and investment decision making. And in 2020, and as we know today, real-time data processing is all the rage in banking. Today, banks are investing heavily in real-time data processing and analytics. They use big data to respond rapidly to market changes, customer interactions, and security incidents. Big data infrastructure for banking sectors. The paper chosen here investigates big data service architecture, its scalability and security capabilities in the banking sector, and presents a 7-layer framework for big data applications. It also discusses the challenges in scaling and securing data using big data, as well as the combination of cloud computing and big data technologies. Finally, it summarizes some practical application scenarios of big data technologies in the banking sector. Big data architecture process. The paper discusses the role of software architecture in designing scalable and secure big data systems in the banking sector. It covers topics such as data governance, managing systems, protecting the quality of service and assurance, security and privacy, data management, data collection, data storing, data mining, data publishing, and more. The paper talks about the challenges and solutions of information security issues in the age of big data. It suggests the use of a multiple layer architecture as an option for dealing with big data. The paper emphasizes the importance of protecting user data and ensuring privacy in big data systems. It also highlights the internal IT challenges posed by big data buildouts and the need for proper data management and processing techniques. Building a big data architecture is an ongoing process that requires continuous improvement, adaptation to changing requirements, and the integration of new technologies. Big data architecture is not a one-time project, but an ongoing endeavor. As data volumes, sources, and requirements change, the architecture needs to adapt and evolve. Business needs and objectives are not static. They evolve over time. As the organization's strategic priorities change, your big data architecture must be flexible enough to accommodate these shifts. It's essential to align your architecture with your organization's objectives and ensure it can support your data-driven initiatives. Regular evaluations, technology assessments, and strategic alignment are essential to ensure that your big data architecture remains a valuable asset to your organization over time.
7-layer framework for big data applications. The paper suggests the use of 7-layer framework for developing big data applications. This framework can be summarized in 3 stages as multiple data sources, data analysis, and data presentation. The 7 layers of the framework are: first, data sources. This layer involves the collection of data from various sources, including social media, sensors, and other devices. Second, data injection. This layer involves the processing of data from various sources, and the conversion of data into a format that can be used for analysis. Third, data storage. This layer involves the storage of data in a distributed file system, such as Hadoop distributed file system. Fourth, data processing. This layer involves the processing of data using various techniques, such as MapReduce, to extract insights from the data. Fifth, data analysis. This layer involves the analysis of data using various tools such as machine learning algorithms to identify patterns and trends in the data. Sixth, data visualization. This layer involves the presentation of data in a visual format such as charts and graphs to help the users understand the insights gained from the data. Seventh, data access. This layer involves the provision of data for various users, such as analysts and business users, through various interfaces, such as APIs and dashboards. Challenges in scaling and securing big data. The paper discusses several challenges in scaling and securing big data in the banking sector. Some of these challenges include: first, data volume. The sheer volume of data generated by the organizations, individuals, and sensors every second in every field makes it nearly impossible for the data providers to supervise or control all the data they actively or passively provide to others. This increases the risk of information leakage. Second, data governance. The procedures to manage data across all systems, including provision for compliance, security, deletion, transfer, storage, handling, and processing, are critical for ensuring the security and privacy of user data. Third, managing systems. Contemporary Lambda architecture big data is often developed on large-scale distributed clusters which are highly scalable and require constant monitoring via centralized management interfaces. Fourth, protecting quality of services and assurance. Ensuring the quality of service and assurance of big data systems is essential for maintaining user trust and preventing data breaches. Fifth, security and privacy. Organizations use various methods of de-identification to ensure security and privacy. The most common solution to ensure security and privacy may be oral and written pledges. Six, internal IT challenges. Big data build-outs can disrupt current data applications, including the use of machine learning technologies for deep big data analysis. Proper data management and processing techniques are necessary to address these challenges.
Cloud computing and big data technologies. The paper discusses the combination of cloud computing and big data technologies. It highlights the challenges in scaling and securing data using big data, as well as the practical application scenarios of big data technologies in the banking sector. The paper also briefly introduces the big data infrastructures that support the big data collection and storage technologies and tools which would be used in this sector. Overall, the paper emphasizes the importance of developing effective big data systems in the banking sector and provides insights and solutions for addressing the challenges of designing scalable and secure big data systems. Practical application scenarios of big data technologies in banking sector. The practical application scenarios of big data technology in the banking sector, as mentioned in this paper, are: first is fraud detection. Big data technologies can be used to detect fraudulent activities in the banking sector. By analyzing large volumes of data, banks can identify patterns and anomalies that may indicate fraudulent activities. Second is customer segmentation. Big data technologies can be used to segment customers based on their behavior, preferences, and other factors. This can help banks to personalize their services and improve customer satisfaction. Third is risk management. Big data technologies can be used to analyze risk factors and predict potential risks in the banking sector. This can help banks to make informed decisions and mitigate risks. Fourth is the customer service. Big data technologies can be used to analyze customer feedback and improve customer service. By analyzing customer feedback, banks can identify areas for improvement and take corrective actions. Fifth is marketing. Big data technologies can be used to analyze customer behavior and preferences, which can help banks to develop targeted marketing campaigns. So, security and privacy challenges triggered by the 5 Bs. The paper discusses the challenges and risks of security issues that are triggered by the 5 Bs of big data, which are volume, variety, velocity, value, and veracity. The challenges include interaction with individuals, re-identification attacks, probable and provable results, economic effects, and the need for a legal framework to share the benefits of data for organizations with individuals. The paper emphasizes that many of the security and privacy challenges do not stem from technical issues but are based on legislation and organizational matters. So let's discuss 5 Bs in detail. First is volume. This refers to the sheer amount of data. Big data involves data sets that are extremely large, often much larger than traditional data sources. Managing and processing such massive volumes of data can be a significant challenge. Second is velocity. This represents the speed at which data is generated and how quickly it must be processed and analyzed. With the advent of the internet, social media, and sensors, data can stream in real time and decisions need to be made quickly. Third is variety. Big data comes in many different forms, including structured data, as seen in databases, semi structured data, example XML and JSON files, and unstructured data like text, images, and videos. Dealing with this variety requires flexible data storage and processing techniques. Fourth is veracity. Veracity refers to the quality of the data. Big data sources often contain a lot of noise, errors, and inconsistencies. Ensuring the accuracy and reliability of data is crucial for meaningful analysis. Fifth is value. Ultimately, the goal of collecting and analyzing big data is to derive value from it, extracting insights, making data driven decisions, and finding business opportunities are the driving factors behind big data initiatives. So the 5 Bs can be achieved in these 3 ways. First is infrastructure security by maintaining Hadoop security, cloud security, and preventing distributed denial of service attacks. Second is by maintaining data privacy, which can be done by encryption, data anonymization, and access control. Third is data management, which includes key management, data provenance, and auditing.
Conclusion and future trends. The conclusion of the paper is that with the swift development of modern information technologies, data has become an important basis for the development of production materials and technologies. The paper investigated the big data service architecture, its scalable and security capabilities in banking sectors based on big data and some current big data application scenarios. The paper talks about two major future trends. The first trend is the emergence of the data fabric, which is a comprehensive system that can access many external data points in real time. With Data Fabric, banks and financial organizations would be able to retrieve information and relay it to the destination systems with lightning speed. The reliability of data will also increase and improve gradually with this trend and approach. The second trend is the integration of artificial intelligence or AI with big data. AI is a critical component of big data solutions as it is necessary for analyzing the vast amounts of gathered information. However, its algorithms are often a black box. In the future, they are going to become more open, which would lead to additional improvements and higher ROI. The paper suggests that a more transparent approach towards integration of AI with big data would be an important factor to consider in the future. This is the link to the research paper that has been used as a reference for this presentation. Thank you.